Okay, question 9. We've been given a cubic function x cubed, and we can see by the shape of the graph, this is a cubic function. We are only given a turning point and nothing else really on this graph. So with very limited information, we've got to show that p is -5 and q is -4. And p and q are sitting in the equation here. So this is a very fancy way of asking you to get the equation of the cubic function. So the rule of thumb with maths, if you have two unknowns like p and q, you're going to need two equations to solve for those things. So the first equation we're going to get by substituting this point into the original function. So I'm going to grab my original function and then I'm going to sub this point into it. Remember, when you sub it in this point, the first one is the x value, so that will go into these three x's. And the second one is the y value, so that's f of x here is a fancy placeholder for y. So I'm going to change it to -9. And then once that's out the way, I'm going to start to simplify this thing. So I'm going to have 2 cubed, which is 8. 8 times 2 is 16. Remember, you can also chuck that in your calculator to help you out. 2 squared is 4, 4 times p is 4p, 2 times q is 2q, and this plus 3 can stay behind. And now I want to go on a bit of a mission to simplify this equation. So I'm going to take this 16 over, and I'm also going to take this 3 over the equal sign. And remember, they become the opposite sign of what they used to when you do that. So this will turn into -16, this will turn into -3. And then -9, -16, -3, let's chuck that straight in the calculator. If I just pop that in, press equals, it gives me -28. Don't exhaust your brain doing mental maths. Use your calculator to help you out. And I see a little bit more simplification that can happen. I can divide everything by 2 just to make my life a bit easier. Okay, so that pretty much wraps up the first equation. Now, to get the second equation is a bit of a challenge. You've got to know your stuff to get the second equation. So we've been given the coordinates of a turning point. Now, if we think of a tangent that runs through the turning point, it's a horizontal line. And the gradient of a horizontal line is 0. And we can start working with our gradient if we derive this thing, because the first derivative is a placeholder for gradient. So I'm going to derive this thing using the power rule. So f of x will turn into f dash x when I derive. And now when I use the power rule, I say 3 times 2, that gives me 6. And then I'll subtract 1 from this exponent, so x cubed will turn into x squared after I subtract 1. So my first term here will be 6x squared. Okay, now if I do the second term, 2 times p is just 2p, and then this x squared will turn into x to the power of 1 after I minus 1, and x to the power of 1 is just x, so I just get 2px. And now the last one, or the second last one, this x will just fall away, and I'm just left with a plus q, because it's x to the power of 1, 1 times q is just q. Then if I subtract 1, I get x to the power of 0, and x to the power of 0 is 1. So I just get plus q, and this plus 3 disappears, boss. Takes a walk, but... And I've successfully done my first derivative. Now, f dash x is my gradient. You must say that to yourself 100 times until it soaks in. F dash x, or my derivative, is the gradient. It's a placeholder for the gradient. So I'm going to change this to the gradient of 0. And then that gradient happens at the x value of 2. So I'm going to put 2 into the x's place here and here, because that's where this gradient of 0 happens. And then we're going to go on a bit of a mission to simplify this. 2 squared is 4. 4 times 6 is 24. Use your calculator to triple check that. 2 times 2 is 4, glue the p on, and we get 4p over there. Right, we are starting to get somewhere. Now I can start the process of simultaneous equations with this equation, as well as this equation. So I'm going to want to get q on its own here. You can also do it here, it doesn't really matter. I think this one looks a bit easier to me. So I'm just going to move that 2p over and it becomes minus 2p. And after I've moved it over, this whole thing is equal to q. So I'm going to put this whole thing in q's place over here. Okay, and then once that's done, I can work on solving for p. So because I've got a plus in front of the brackets aren't really necessary, and I can get rid of this plus at the same time. Yes, much better. Okay, so let's get the numbers on one side and the letters on the other side. So I want the p's to stay on the right hand side, and I'm going to move the 24 and the minus 14 over to that side, and when you move them over, they're going to change sign. Right, minus 24 plus 14 is minus 10. 4p minus 2p is 2p. And then I'm just going to divide both sides by 2 to get p on its own, and we get p to be negative 5 as we expected. Okay, and then we still have to get q. So I'm going to take this p value, I'm going to put it into p over here, and then it's going to spit out q. Okay, so I just take that, put it in there to get that. And ain't nobody got time for that. Yes, I'm not working that out. It's going straight in the calculator, but I can give you a good prediction of what it'll be. I think it's going to be negative 4. Nice. Yes, check that out, bro. Okay, so q is negative 4, and we are officially done. Yes, behemoth of a question, this one. Okay, so if we have a look where the marks are coming from, our first mark comes from the substitution into this line, so chucking this point in here. This must be a negative 9, sorry. Your second mark comes from making the derivative 0 over there. So if you know this tangent story with the gradient is 0, you get a mark for that. Substitution of x equals 2 gets us our third mark. Solving for p through this whole process gets us our fourth mark. And our fifth and final mark comes from solving for q. Just take note, you don't get marks for the answers here because the answers are given to you. Okay, we are asked to get the y-intercept of f now. To get the y-intercept of f, we're going to need its equation. And that was the fat mission we went on in 9.1. So what I'm going to do is, I'm going to grab the equation. Here's the equation. And I'm going to fill in p and q into this thing so that I have the full equation. Okay, and then to get the y-intercept, we're going to use our universal rule. To get the y-intercept, I make x equal 0 and then solve for y. So I'm just going to change all these x's to zeros, and let's see what it spits out. Okay, now you can pop that in the calculator, or you can just kind of read this number. This number at the end is always the y-intercept for a cubic function, because all of these will simplify to 0, so I just get 3 left over. Okay, and then just make sure to write it as a coordinate as the question instructed. So the y-intercept does have a name, it's named g, so I'll just get rid of this y-int and put a capital G in front of this coordinate. Okay, and your 2 marks only come from the x value and the y value of g. So you didn't even have to show working out, but it's good to know how we get there. So it's never a waste of time. Okay, so now we've been given the point C. It's 3 and 0. So let's fill that in on our sketch quickly. And now with that point, we need to calculate the distance between A and B, the x-intercepts. So we need this distance here from A to B. Okay, to do that, we're going to need the coordinates A and B. And A and B are very special coordinates. They are x-intercepts. And then our universal rule to get x-intercepts, we make y equals 0 and solve for x. Okay, so just remember f of x is a fancy placeholder for y. So I'm going to make this 0. I'm going to change that to 0 and it's going to equal this thing. Okay, so after making y 0, I've got to factorize this thing. Okay, so that's going to be quite a challenge. There are 3 acceptable methods to factorize a cubic equation. The first method is inspection. You just do it by looking at it, which is my personal favorite. The second method is synthetic division, which I will show you in this question. And the third method is long division, which I do not like doing. I'm not even going to show you that in this video. I like avoiding that method. So let's go ahead and start with inspection. Okay, so when you factorize these, you're always going to get a small bracket times a big bracket. Or better yet, a binomial times a trinomial. So it's good to know that because you're going to get 2 terms in this bracket, and you're going to get 3 terms in this bracket. Now to get the factor that goes in the first bracket, you normally just have to use trial and error, but that's why they gave us this point, so that we don't have to use trial and error and we can fill this bracket in straight away. So what goes in this bracket is x minus 3. It's always the opposite sign of the x-intercept. Okay, now we can start working on getting our trinomial. So this one times this one has to give us 2x cubed. So this one has to be 2x squared, because 2x squared times x will give me 2x cubed. Okay, now we're going to do a similar thing for this one multiplied by the one at the end of the trinomial. So this one multiplied by this one must give me plus 3. So it stands to reason that this one has to be negative 1, because negative 1 times negative 3 will give me this plus 3 that I'm looking for. And now it starts to get tricky to get the middle term here. So you start off by multiplying these two. And if I multiply these two, I get minus 6x squared. But I need minus 5x squared. So I've got to add or subtract something to this to get minus 5x squared. So I need to add 1x squared. So minus 6x squared plus 1x squared will give me the minus 5x squared I'm looking for. So this one times the middle one here needs to give me 1x squared. So then this one will just be plus 1x, or even better, plus x. And now that we've got that, we've officially finished with inspection, and we can start factorizing this trinomial. Before I do that, let me show you synthetic division. Okay, now with synthetic division, you start off by drawing a box like this. Okay, once you've drawn like your sort of half box, you put the coefficients over here. So I'm going to put 2, I'm going to put minus 5, I'm going to put minus 4, and I'm going to put 3 over there. And then I put my factor on the outside. So my factor is 3, so I put the positive version of 3 over here. Okay, now we can actually start with synthetic division. So the first thing I do is I bring this 2 down outside the box. After I bring it down, I multiply these two numbers. 2 times 3 gives me 6, and I put that number here. And then I add these two numbers, so minus 5 plus 6 is 1. And now I start the process again. So 1 times 3 just gives me 3, so I put that 3 over here. And then minus 4 plus 3 will give me minus 1. And then minus 1 times 3 gives me negative 3. I'll chuck that over here. And then 3 plus negative 3 will give me 0. This last number must always be 0. If it's not 0, something went wrong. And then these three numbers form the coefficients for my trinomial. So I'm going to get 2x squared as my first term in the trinomial. For the second term in the trinomial, I'm going to get plus 1x or plus x. And for the last term in the trinomial, I just get minus 1. And then I've used synthetic division successfully to factorize this cubic. So it's up to you to choose which method works for you best. So yeah, the one that makes more sense, choose that one. Okay, so now I've got to factorize this trinomial. This bracket will just stay where it is. Okay, so I've just set up the shell of brackets to factorize this thing. And I'm going to use the tennis court method to factorize it. So I'm going to put the factors of 2 underneath each other. And then I'll put the factors of 1 underneath each other over there. And then I multiply across, like I'm serving in tennis, you go across the court. Okay, now I need to use these two numbers to get this plus 1 in the middle. If I say plus 2 minus 1, it will give me the plus 1x in the middle. And then I transfer these signs into the tennis court. So this minus goes over here, this plus goes over here. And then I chuck a little x here, chuck a little x here. And I officially have my 2 brackets. 2x minus 1 will go in there, and x plus 1 will go in there. And now I make each separate bracket equal to 0. So x minus 3 equals 0, this bracket equals 0, and what's inside this bracket equals 0. Okay, just make sure to separate those with the word or. And now I'm just going to solve for x with each one. So over here, I take the minus 3 over, it becomes plus 3. Over here, I take the 1 over and then divide by 2 on both sides, so I get a half. And over here, I take the 1 over and it becomes negative 1. And now that I've got my 3 answers for x, I've got to decide which one belongs to who. So we do that based on based on their position on the Cartesian plane. So we already know C is 3, so we can kind of ignore this one. Now we've got an option between a half or minus 1 for B. B is on the right hand side of the y-axis, so it must have a positive x value, so this will be the half. And then A will be the negative 1, because we can see it's on the left of the y-axis. So it has to have a negative x value. Okay, now we're almost at the finish line. To get the length of a horizontal line, it's the one on the right minus the one on the left. Okay, so the name of our horizontal line is AB. So I'm going to change the name here to AB. Okay, the x value on the right is a half. And the x value on the left is minus 1. Just make sure to keep it in a bracket. Okay, and then let's work that out quickly. A minus and a minus give us a plus. So it's a half plus 1, which is 1.5. Written as an improper fraction, that will be 3 over 2. And then I'll just slap the word units next to that. Okay, and now before we look at where the marks come from here, I want to show you a nice little calculator trick, but it only works on the white calculator. Okay, so I can double check if these answers are correct using the white calculator. And how I do that, I click on mode, then I go to equation number 5, and then I want the cubic equation. You see x cubed there, so I select number 4 to activate the cubic equation. Now it wants the numbers in front over here. So the first number is 2, so I'll put that in A's place. You press 2 and then equals, and then minus 5 equals, and then minus 4 equals, plus 3 equals, or just 3, and I'll press equals again. Okay, there's my first answer for x, it's 3. There's my second answer for x, it's a half. And if I press equals once more, I get the last answer for x. What a beautiful little function. And bringing this question to a close, let's have a look where the 4 marks come from. You get 1 mark for the correct trinomial after factorizing. You get 1 mark for the correct 3 brackets or 3 factors. The next mark comes from the correct 3 roots over here. And the last mark comes from the correct final answer. Question 9.4 asks us to get the x coordinates of M, the turning point of F. Okay. To get the turning point within calculus, there is a procedure to follow. And bear in mind, this procedure works for all functions, not just cubic functions. Okay, and this is our procedure to follow. We're going to get the first derivative, f dash x. So we're going to derive this thing. And then we're going to change the first derivative to 0, because turning points have a gradient of 0. And then we're going to solve for x. And we don't have to do this last one, because I only want the x coordinate. We don't need the y value or the y coordinate. So let's get rid of that last point and follow our procedure. Okay, so we just grab the equation for our cubic function. Then we start off by multiplying these two numbers. They're going to give me 6. And then after that, I subtract 1 from this exponent. And I'm left with x squared after I say 3 minus 1 to get this 2 over here. Oh, this one is missing a square. Okay, let's repeat that process with the power rule here. 2 times negative 5 is negative 10. Then I subtract 1 from the exponent, which leaves me with x to the power of 1, also just x. Okay, and then I do it over here. If there's no exponent, we assume it's a 1. And I'm going to actually use the shortcut. This x just disappears, and I'm just left with minus 4. And this 3 also takes a walk. He gets out of here, bro. And now we've successfully got our first derivative. Okay. Now we're going to change f dash x to 0. Okay, and once we do that, we can start solving for x. So I smell a common factor of 2 here. Yes, something's cooking in the kitchen there, boss. Alright, so let's divide everything by 2 to get rid of that common factor. And once I've done that, this thing is ready to be factorized. So because the number in front of x squared is a 3 and not a 1, I've got to have to use the tennis court method. So I'm going to set that up over here. Factors of 3, it's a prime number, so just 1 and 3. And then I write the factors of 2 next to that, also a prime number, so I'm going to write 1 and 2. And then we're going to multiply going across. Okay, and if I multiply going across, 3 times 1 gives me 3, 1 times 2 gives me 2, and I need to use these two numbers to get that minus 5 in the middle. I can accomplish that by saying plus 3 plus 2. Sorry, I need to get minus 5 in the middle, so this needs to be minus 3 minus 2. And then we transfer those signs back in, and then we've got our 2 brackets. But we have to hold on a little second. Something's not quite right here. If I say minus 1 times minus 2, that's going to give me positive 2 and not negative 2. So that indicates the arrangement of my factors is wrong. So I've actually got to start again over here. So what I'm going to do to start again is I just swap the order of these two. Now we multiply across like we serve in tennis. Now I need to use 6 and 1 to get minus 5. So I'm going to say minus 6 plus 1. And then we transfer those signs back in. And then I chuck a little x here, chuck a little x here. And then I'm done. So with the tennis court method, you must always just multiply these two numbers together. And make sure that they're giving you this last number here. That is a big trap that they like to put in matric. So just triple check that. Alright, so here's our two brackets, x minus 2 and 3x plus 1. And then using those two brackets, we can get our two answers for x. So the first answer for x is x equals 2. And then the second answer, if I take this 1 over, it becomes negative 1. Divide both sides by 3, so I get negative a third. Okay, so I'm not quite finished. I still need to tell them which one is the x-coordinate of m. So you can see we've got two answers here because we've got two turning points on the cubic graph. And the 2 belongs to n. So this minus a third must belong to m. So I'm just going to put a stroke through the equal sign here to reject that one and show them this is my final answer. And our 3 marks in this question will come from the correct first derivative, the correct factors, as well as the correct x value for m. Just one last thing with this question over here. It's always nice to check if you did these correctly. So there is a function on the white calculator that does that. If we go to mode equation number 5 and we select the quadratic equation, the x squared, number 3, and we just feed it these numbers, 3 minus 5 and minus 2, 3 equals minus 5 equals and minus 2, then we press equals, Then it gives us our first answer of 2 and our second answer of minus a third. Brilliant little calculator trick to check if you did everything correctly over here. Next up, we've been instructed to determine the x-coordinate of h, which is the point of inflection of f. Okay, to get the point of inflection, there's a procedure you must follow. Very similar to the last procedure with turning points, but one crucial difference. We now work with our second derivative, so we derive it twice, and then we change the double derivative to 0, and then we solve for x. And we don't need to do this last one, we don't need the y value because they only want the x coordinate, so we can get rid of point number 4 here. And now I'm going to start with this process. So I want to get the second derivative. Bear in mind we do have the first derivative from the previous question. So I'm just going to copy paste these two steps over here in my work. And then to get the second derivative, I derive this thing over here, the first derivative. So now we're going to get f double dash x equals. And then I use the power rule once again to differentiate. 2 times 6 gives me 12. And 2 minus 1 just gives me x to the power of 1, which is just x. And then this minus 4 beats us, he disappears. And this x also disappears, and I'm just left with minus 10 next to this. So I've officially got my second derivative. Now I changed my second derivative to 0. So I'm going to change this to 0 and then solve for x. Okay, I'm going to move this minus 10 over and it becomes plus 10. And then I'm going to divide both sides by 12. And then 10 over 12 can be simplified because they're both even numbers. So they can both be divided by 2 and I'll be left with 5 over 6. Bear in mind your calculator can check that for you as well. So I'll just say 10 over 12 and it will simplify to 5 over 6 for me. And then lastly, let's check where our 3 marks are coming from. The first mark comes from your double derivative. The second mark comes from making the double derivative equal 0. And the last mark comes from the correct x value of 5 over 6 for h. Then 9.6 asks us for which values of x will f be concave up. So they're asking you like kind of which part of the cubic function is the happy part, and like your point of inflection is your cutoff point here. So that's where it changes from happy to sad. So let me show you a better way to see that. So basically from the point of inflection to the right is where it concaves up. It's like a happy face parabola. And then from the point of inflection to the left is where it concaves down. It's like a sad face parabola. And they want to know where it's going to be concave up. So it starts here at this x value and goes on to infinity. And there is another notation you can use for your answer. You can say whenever x is greater than 5 over 6. And it does not include 5 over 6 because it's neither concave up nor down there. It's a special point. It's the point of inflection. And then your 1 mark just comes purely from either one of these answers over here. Okay, and then 9.7 is a rather tough one. I'm not going to lie. It's a difficult question. So I'm going to grab this and analyze it quickly. Okay, so what it's saying is this is the y value of the graph. F dash x is the gradient. You've heard me say it about 10 times now. And then less than 0 is a fancy way of saying negative. So when I multiply the y value by the gradient, I want a negative number. Okay, so you start all the way on the left of the graph to analyze this. Over there, I've got a negative y value. And then we can see the graph is going uphill over here. So it's got a positive gradient. And a positive times a negative will give me a negative. So it's working in this small region over here. So that starts at negative infinity and ends at minus 1. So I kind of write that down, forget about it, and then I start analyzing afterwards here. Okay, so now after negative 1, we all of a sudden have a positive y value because we're crossing the x-axis. So the graph now has a positive y value. So we've got a positive y value. The gradient is still positive because it's still going uphill. So it's not working now. A positive times a positive will give me a positive, and that's not what I want. But things are going to change after I cross M. Now all of a sudden the gradient is negative. So it's working from here to here because the y value is positive, but the gradient is negative. So I'm getting a positive times a negative. So it starts at -1/3 and it ends at 1/2. And another small note here, I'm using circular brackets everywhere because it does not include any of these because there's no equals to sign over there. Okay, now when I cross this point, I start getting negative y values again. So now from here to here, I've got negative y values as well as a negative gradient. And a negative times a negative will give me a positive, so it's not giving me what I want. But things will change when I cross this point. Now all of a sudden the gradient is positive again. So it's working again from here to here because I've got negative y values as well as the positive gradient. So it's working from 2 to 3. And then once I cross over this point, I get positive y values again coupled with a positive gradient, so it won't work after that point. So if that's the case, here lies our final answer. Bear in mind there is another way to state the answer. Let me show you that quickly. So this is the other way to state your answer. Whenever x is smaller than -1, it means the same thing as this. Whenever x is in between 1/2 and -1/3, it means the same thing as this. Or whenever x is in between 2 and 3 will mean the same thing as this. Now let's have a look where our 3 marks come from and wrap up this demon question. So the 3 marks are received from each respective interval. This interval gets marked, this interval gets marked, this interval gets marked. Or if you use this notation, each one of these little blokes will get the mark.